Hello, my name is Todd Wetter, and this presentation is going to give us a brief overview of fire behavior. In this presentation, we'll look at the 5 classes of fire and discuss the fire growth process and each of the different fuel types associated with those fire classes. We'll also compare pre-mixed and diffusion flames. We'll explain the heat of combustion and combustion efficiency, and we'll review the fire triangle and fire tetrahedron and describe the dangers with smoke and how they affect flames. So what is fire? We've all seen fire and we use it in our daily lives, but what exactly is it? The National Institute of Standards and Technology, or NIST, uses the definition of a rapid oxidation process, which is a chemical reaction resulting in the evolution of light and heat in varying intensities. Fire, therefore, is more of a process than a thing. It's similar to the process that you see with rust on metal or the browning of a potato or apple when you cut into it. It's just an accelerated rate. Fire needs 3 components: fuel, heat, and oxygen. These 3 components make up what we know as the fire triangle. To have fire, it is essential to have all 3 of these elements available. A fire will continue to burn until one of these elements is removed or eliminated. Conventional methods of extinguishing fires focus on eliminating the fuel, heat, or oxygen. The fire tetrahedron introduces an additional element to the fire triangle, which is essential for combustion to take place. The updated model illustrates that a chemical chain reaction must exist between the fuel and oxygen alongside heat. Similar to the fire triangle, extinguishing the fire occurs when any one of the components is eliminated. But in this case, if the chemical chain reaction is disrupted, the fire will also be extinguished. So looking at our fire classifications, if you've ever taken a class on fire extinguishers, the fire classifications may be familiar to you. The 5 classifications are based on the type of product that is being burned. A Class A fire are made up of ordinary combustible fuels such as paper, cloth, wood. The primary extinguishing method for these types of fires is cooling by using water. Class B fires are flammable or combustible liquids and gases. These types of fires tend to burn on the surface of the product or in areas where the gaseous mixtures may collect. For this reason, removing the air along with cooling the fuel is the method of extinguishment. In Class C fires, many of the other classes may be present. However, it becomes a Class C fire when energized electrical equipment is on fire. The simple task of disconnecting the electricity from the equipment from its energy source will stop the fire from being fueled. However, other materials may still be burning and must be extinguished in traditional methods. Class D fires are combustible metals. Many of these metals end in the suffix um, such as titanium, magnesium, or aluminum. These fires can burn at an intense rate and may react violently with water. Large fires may require large amounts of dry sand or dirt to extinguish, while smaller fires may be put out with a low velocity application of a dry powder that's compatible with a specific metal. Then finally, Class K involves fires that occur in kitchens that use vegetable oils instead of animal fats in their fryers. They're different from traditional extinguishing methods, as Class K use a process called saponification. When applied to the oils, it changes into a soapy mixture that sits on top of the oil and it acts as a blanket, preventing vapors from escaping, and also smothers the fire. The heat of combustion is defined as the amount of heat energy produced when a given amount of substance completely burns. Essentially, it's the measurement of the amount of heat that a material can emit during the combustion, and is frequently used to compare the energy content of various fuels. The degree to which fuel burning is being used effectively during combustion is known as combustion efficiency. Because the inefficient diffusion of oxygen into the chemical reaction and the loss of heat to the surrounding atmosphere, the combustion efficiency of fire is never over 100, or never quite 100%. It never will burn to that 100% mark. There will always be product left over. There are two ways to add oxygen to a combustion reaction: premixing or diffusion. Diffusion of oxygen into fuel gas region to support combustion is the cause that we most commonly are going to run into as fire safety professionals. In a diffusion flame, oxygen is introduced to the oxygen at combustion site, typically through air. Where the fuel and air mix are within the fuel's flammable range, the ensuing combustion takes place. In a premix flames, those are they have air introduced into the fuel stream, where the fuel is mixed with the air before ignition point, which also results in a more efficient combustion, such as like a Bunsen burner or a torch. Smoke is made up of gases, solids, and liquid particles that are released into the air when a substance burns or goes into pyrolysis. On top of being toxic or having toxic properties, the makeup of smoke will cause both long-term and short-term problems with when people are exposed to it. Smoke is also made up of unburnt fuel that may ignite if the conditions become right. The difference in flame and smoke is related to the type of fuel it's burning, the amount of oxygen available, and the temperature of the flame. Smoke will decrease in density as the heat of the flame rises, and it becomes a cleaner burn. I hope that gives you a good overview of fire behavior. Thank you for your time.